All right, I'm going to get started. In case you don't know where you are, you've wondered how you ended up into this session. This is a work group session that is around auto-grading and automatic feedback with GitHub. So this is going to be a little bit more advanced than a couple of the other workshops that we've had or some of the other introductory sessions, but hopefully it will seem easy when we're done with it. So before I get started, I should probably hit the play button and tell you who I am. So my name is Jeff Rafter. I am an engineer at GitHub, and I'm working on the GitHub for Education team, which is really exciting because I have a strong passion for education and for computer science. And this finds me in this perfect spot where I get to work on these tools. And so everything that I'm about to show you, I either helped build or built. These are my features. And so I'm probably more excited about them than I ought to be, but hopefully you are too. So what is it that we're doing here? So we're using this auto grading and auto feedback to help our students learn how to use Git and GitHub. So you might have shown up to this session and you're wondering, what is Git or what is GitHub? And those are fantastic questions. This presentation is not going to talk about what Git and GitHub are extensively. There was a really great presentation this morning from Jeff Olson, another from our own Stephanie Lopez. I would check those out. If you have no idea what Git and GitHub are, definitely go watch those, but don't do it right now. Instead, I'll give you a really quick introduction. So Git is just a version control tool. It saves multiple versions of your code, and it allows students to save their work as they're working on their progress or going back to something if they make a mistake, and it allows them to continue and collaborate with one another. So it's a fantastic way to not lose track of what you're working on. And for teachers, it allows you to see how students are progressing. As they're turning in their work and constantly making changes, you can check their work and offer feedback as they move along. And so how do you do all of that? Well, that's where Github Classroom comes in. So Github Classroom is a tool that we've built around Git and GitHub that allows teachers to have pre-configured assignments using template repositories and allows students to get individual work assignments and group work assignments and turn those in their own kind of private way. So that's the context for what we're doing. There are far better introductions to Git and GitHub and GitHub Classroom than that. But we'll move on for the time being. Also, please feel free to ask questions in the chat. I'm really excited to answer questions. And there are other folks from GitHub here that are also eager to answer questions. So if you have a specific question, please ask it in the chat. All right, so for this workshop, what we're going to do is I'm going to give you a quick overview, and this will be a lightning fast overview. It will probably be presented by someone who is an engineer and not a professional teacher, but you'll see that building an assignment and grading those assignments can be pretty quick. And then once we're done with that quick overview, we'll actually go through and we'll try it click for click. So this first introduction will seem a bit more like an overview and won't be as detailed, and then we'll dive right into the detail. That way, it makes it a little clearer where we're heading and how we're doing it. I'll pause really quickly just to see if there are any questions that I'm missing. But I think that we're great. Okay, so I'm just going to continue on. Okay, so with our assignments, inside of the GitHub for Education organization on GitHub, we have a lot of examples of how to set up auto grading. Now, the auto grading that we have at GitHub supports any variety of languages, but we have built-in support for Java, for Python, for JavaScript, for C and C++. Basically, any language that you can think of, we have an example for it. And we'll be using the example for auto grading that comes in Java. Now, if you're not teaching Java, if you're not familiar with Java, hopefully the code examples here will be incidental. They'll be really simple. You don't have to have an extensive knowledge of Java to understand what we're going to show. And also, if you are familiar with Java, you might be thinking, oh, those examples are too simple. So hopefully we've hit that middle ground pretty well here. So for our example, we're going to start with some code. And this is an assignment that we might create for our students and then give them this code. And so we're starting with a basic Hello World application. Now you notice that this program doesn't say Hello World. In fact, it says not the right string, tests will fail. And so we're starting them off with code that is not working. And we think that that's a good way to kind of get students the idea of what the code shape should look like and begin to answer questions as quickly as possible. So with this example, we're going to test that the code says Hello World using Gradle. Now, this is where, if you're not familiar with Java, things get a little bit more complex. But this is an automatic test. And so when you're learning Java, oftentimes you'll use Gradle or you'll use Maven. and you'll run the code. And so as the code executes, we expect it to print hello world out to the terminal. And that's all this is checking to make sure that it actually said hello world exclamation mark to the terminal. So if a student were to work on this test normally without GitHub Classroom, they would download the repository and they would run the tests the moment that they started. And it would say Gradle test. And they would see that it failed and they would be confused. They would say, why is this failing? They would go fix their code and they would run Gradle test again and the test would pass. So the test hello world test was successful. And so this is the normal workflow before you actually integrate GitHub or GitHub Classroom. Within GitHub Classroom, though, you can actually create this as an assignment as a teacher. So the teacher part of the workflow looks like this. You get to GitHub Classroom, which is classroom.github.com. You sign up. It's a no-cost sign up. This is a completely free tool for you to actually build a bunch of different assignments for your students. And this tool here has, in my example, EduCats University. So I've created a classroom for all of the fellow EduCats that I work with. And you can see there's a variety of assignments that are already in here. And you can create a new assignment. So clicking on the new assignment button will allow you to start working on the assignment basics that you have. So for example, I've created an assignment called Say Hello in Java. And then I go ahead and I add a starter code repository. Now, remember that I said that there are some examples. This is using that example starter code repository that was the template that we just looked at. So selecting that, I can actually go through and add an auto-grading test. And again, we'll go through these steps in detail. I'm jumping ahead a little bit here. But we've created a test here, and the test is called Say Hello. And all it's going to do is run that Gradle test that we saw in the command line from before. So one other little note that I'll do as I'm setting up this assignment, I'm going to click the Enable Feedback Pull Requests. Now, this is kind of the magic of using GitHub Classroom, is that you can actually have a conversation with your students in the tool about their code as they're working. And so as they make a change and they push that change up, they'll see whether or not it was successful. And you can comment right there on that and they can ask for help, which is fantastic. So from a student's perspective, they're going to go ahead and accept the assignment. So you'll generate out a link that is individual to the assignment, and the students will click on that link and they'll end up at a page that looks something like this. So they can accept the assignment by clicking the large green accept this assignment button. It's pretty obvious. And a number of progress bars will run. We'll set up a repository on GitHub for them. And once it's ready, they can click right through and it says, you're ready to go. They can click on that assignment. And this is what the student sees. Now, I'm going to jump back to the beginning here, because if you're a brand new student to computer science and you've just heard about Git and GitHub for the very first time and you end up on this page, it can feel a little bit overwhelming. And so this is where I'd refer back to either Jeff Olson or Stephanie's talk. This is a place where you really need to walk students through this experience before they get here for the first time. Otherwise, it's going to feel a little bit intimidating. As a professional, this is my everyday. I build all of my stuff on GitHub, so this feels really familiar to me. But I have to remember that, first time seeing it, it can be very confusing. So here in this example is a README, and it's going to explain what the assignment is about. And it says that the tests are currently failing because there's an output mismatch. So you have to fix the system out print line in the main method, and it will make the tests green. And so this is an opportunity for the students to go work on their code. And so we're going to make sure that we're giving them feedback as they go. And so we've created this pull request. So a pull request is a common way for a person to submit their changes and have them reviewed. In this case, the student will be submitting their changes, and we, the teacher, will be reviewing those changes and offering them some helpful feedback. What's interesting is you can see that all checks have failed. So this code starts off as failing, and we can see that it immediately failed. Now, as a teacher, if you have 30 students, or if you're in a larger CS university class and you have 100 students or more, it's really difficult to see which students are successful and which students are struggling. And so as a teacher, you can get a quick overview of how the students are progressing. So jumping back to the GitHub Classroom view for a teacher, I can see that student Jeff Rafter, my made up user here, has accepted the assignment and has actually not passed the test yet. Their latest commit has failed, and that's our expectation because they haven't written any code yet. And so we can actually click on the review button there and go and leave them a comment on their pull request. And so I can say, hey, it looks like your tests are failing. The goal here is to make hello world say hello world. So try changing this line, and I can point them directly to the line in their code repository. So here I linked right to it. The student might see that and then open up the code. They could again clone this normally. They could open it up in VS Code or IntelliJ, any kind of tool that has GitHub integration. In this case, I've opened it directly in the code editor on GitHub, which is pretty easy. This is an easy code file. And I've changed it to say hello world exclamation markers, which is what we're supposed to do. Clicking that commit changes button, the moment that the student does that, they see that the checks are starting to run again. And so we can see that this check is in progress. It's going to run the tests and see if they're successful. And in fact, they all pass, which is fantastic. And the teacher on their end can see, oh, hey, check it out. Student Jeff Rafter has actually gotten all of their tests to pass, and they're looking good. Now, it's important to call out that the list of green check marks and red X's here are not a replacement for a grade book. It's not intended to be that at all. It's not they got full credit or they didn't get full credit. What this is really about is an opportunity for you to see how the students are progressing and offer feedback as quickly as possible. So it's more of a window into their work in progress as opposed to the final answer that they get graded on. So that's really the purpose of tests, is to see how they're progressing. And that's pretty much the example that I'm going to show here. Again, this probably feels like it was lightning fast, and it was, but we're going to try and go through this click by click if that makes a little bit more sense. So what we're going to do is we're going to create a new assignment, and I'm going to make this a little bit smaller. And I'll also pause to see if there are any questions. I'll take a quick look at the chat. Doesn't look like there are. Okay, fantastic. So we're going to create a new assignment. And so I'm going to actually open up this CSTA Say Hello repository right here. And you can see this is just a repository that I, as a teacher, have set up. And it has a couple of things that are in here. It has a README that gives some information about how the assignment should look. It has this hello Java and this hello name Java file that are included in them. And hello Java is pretty simple. It's going to be very similar to our hello world test that we just did. But this one just says system.out.println, put the correct string here. We want it to actually say hello world. So the code will fail when we first run it. We also have hello name Java, which is going to accept the code input. So basically, it will say, what is your name? And then wait for the user to type in their name. And then it should say, hello, whatever the person's name is. And so neither of those things are in here. And you also notice that there are actually no tests that are specified in here. So we're going to be doing our tests a little bit different. The last thing that I'll show you is for this template repository. You'll notice that it's a template. In order to make a repository a template, all you have to do is go into your settings and just check this little box that says template repository. So now we have a template. Let's go ahead and create an assignment for our students. And so I'm going to copy this one more time. And I'm going to come back over here. So we're back in our classroom, acting as the teacher, and we're going to click New Assignment. And the thing that we're going to call this here is we're going to call this assignment Say Hello World and Hello to the Person. That's a long name, but you can see that it's kind of slugified here. We could add a deadline to our assignment, so they have to have it finished by a certain time. In this case, we won't do that. We could also specify whether or not they're meant to work individually or as part of a group. I'm also going to skip over that for the time being, but just know that it's available. For our repository visibility, I've set it as private, which is the default. This means that students can't see each other's work. It's also not going to be public, which is really, really beneficial, especially when working in an educational environment. So I'm going to click Continue here. That's all I need on this page. And at this point, we can see if we want to select a template repository. And based on what we just said, we do. And so I'm going to paste in this template repository right here. And all you really need is the username and the name of the template, which in this case is Say Hello. And so we're going to go ahead and click on this. So it's a template repository. All of this looks great. There is another session that you can check out if you're looking to have an online integrated development environment connected to this, like MakeCode or Replit. For now, I'm not going to select an online IDE for this example, but it is really fantastic. Those can integrate really well with Autograding. So I'm going to click Continue again. And here we can add Autograding tests. And so what I'm going to do here, this is a little bit different, but we're going to do an input-output test. So in the input-output test, we're going to call this Say Hello World. And this is just the name of our test here. And our setup command is going to be to compile our Java code. So with Java, it's a compiled language, so you have to compile it before you run any code. And so what we're going to do is we're going to just go ahead and compile it. So we'll do javac star.java, and this will compile all of the Java files in our program. And then what we're going to do is we're actually going to run it using the class path of the local folder, which is -cp dot. And we're going to just say, let's run hello. So this will run the hello program, which should be fantastic. And what we're not expecting any input when that runs, but we are expecting it to say hello world. Hello world. And we can have different kinds of comparisons here. For now, we'll just leave it at included. That's fine. And we're going to go ahead and add points here. The points are completely optional. This is something that you can have for fun if you have a lot of different tests. We'll say that this is worth 5 points. We're just making up a number. They're completely made up in this case. You might have something specific that you need here. So we'll save this test case, and we can see that that test case is there. Let's add one more. So we'll do another input-output test. And this time we're going to say hello to a person. And the setup command is again going to be javac star.java. And this time we're going to say java, oh my goodness, java-cp dot, and we're going to say hello name is the program that we're going to run. Now, remember when we looked at the hello name file over here, we could see that it's actually going to ask someone, what is your name? And it's expecting them to give an answer. So that's actually the benefit of these input-output tests right here, is we can say the input that we want to give it is Jeff, and we're expecting it to say, hello, Jeff, exclamation mark, which is really fantastic. So it'll ask us, what is your name? We'll give it the input Jeff, and we're expecting it to spit out hello, Jeff, right after that. Now, this is a little bit harder for our students, so we'll give them 10 points on this one. Well, let's give them 20 because it's, it's their first class. All right, so we go ahead and we save both of those. We're going to skip over the protected paths for now, and I'm going to click enable feedback pull requests. At this point, I'm done. I can create the assignment, and now all I have to do is teach, which is really the hard part. Setting up the assignment is the easy part. So let's imagine that we've explained to students what's going to happen, how they're going to deal with this, and we're going to copy this invitation link. Now you can kind of do it in either place here, but I'll just click this one right here. So we copy the invitation link. Now we're going to completely switch our persona, and we're going to imagine that we are, in fact, student Jeff Rafter. Student Jeff Rafter is in this class and clicks on the classroom assignment URL that was given out and arrives here at this page and can accept the assignment. So this has created a personalized acceptance for the invitation, and we say accept the assignment. And student Jeff Rafter waits for these beautiful progress bars that are happening. Once they're done, the assignment is ready to go and appears here. So as this happens, you'll see there's a lot of information on this page, and we're kind of waiting for some different things. We're kind of getting an idea, and we can see the instructions. So in hello Java, change the output to be hello world. And in hello name Java, ask the user for their name and say hello to them. So those are pretty good instructions. You can see that in the background, a couple of other things have happened. You can see that tests are now running for our first tests, and they're going to fail because the assignment starts off as failing and we have to make it pass. And you can see that there's already a feedback pull request that has been created. So let's go take a look at that really quickly. And there it is, it already failed. So I'll click into there. Yeah, so unfortunately it failed. Now, if we wanted to, we could start right here and just look at the details of what failed. And so as we come in here and look at this set of tests and put the correct string here, and it's supposed to say hello world, and it says the output for test say hello world did not match. And so we have to fix that. And say hello to a person, the output for say hello to a person did not match. Hello Jeff is what we expected. So it looks like we have a couple things to do here. So what I'm going to do is I'm going to come back to the very beginning of our code. And I'm going to come into hello Java as a student, and I'm going to try and make it work. So I'll quickly type in hello world here and commit that change. Fantastic. Now, as the student comes in, their code is working in the background. We'll switch back over to our teacher persona, and we'll check it out again. And it looks like student Jeff Rafter here has their latest commit has failed. They have 0 out of 25 points so far. So we'll wait for this to happen and then refresh. And it looks like they've still failed. So our change actually still failed, and it looks like they're struggling. So let's click on review from the teacher's perspective. We can come in here and we can actually see what code have they written, and it looks like they've written some code. and it said hello world, we can actually go and look at their progress inside of here. Looks like they updated hello Java. So we can look at this really quickly. And they still have 2 that are failing. So it looks like, oh, it was supposed to say hello world with an exclamation mark, and we only said hello world. So it looks like they have a mistake here, and they're just missing that exclamation mark. So let's leave a comment as the teacher, and we'll just say, it looks like this is close, but you left off the exclamation mark. So we could leave our comment just like that, or we could be really helpful for our students here and offer a suggestion. And so in this case, we're going to come in here, we're going to fix it ourselves, and then we'll just say, add this comment. From the student's perspective, they're over here, and they immediately see that pop up on their screen, and they're like, oh, I totally did leave off of that exclamation mark. And so the student can just commit this suggestion right here, and they can say commit changes. See it working? And unfortunately, and that comment now is outdated. Unfortunately, it's still failing because little did we know there's another test that we have to solve. So there's actually 2 tests in here, not just this one. So we can go and come back to our code. We'll wait for that to kind of do its thing. As a student, we'll come back into our code and we'll try and fix the other test really quickly. I won't go into too much detail on this one, but it looks like we've got to put some extra code here. So let's go ahead and secretly just place this line of code down here. I think just demos, sorry. Okay, and I think this needs an exclamation mark. All right, so we'll go ahead and commit that. Fantastic, so this should start running. Let's jump back over to our pull request. You see that the code has been updated over here. Lots of things are happening kind of simultaneously at this point. And so let's see if this one passes. Coming down into here, code is running. Let's get the details. And should be able to see this as this is going. And it looks like both of them passed, which is fantastic. Jumping back into GitHub Classroom from the teacher's point of view, we can see, hey, it looks like student Jeff Rafter actually did what they were supposed to do. They've got 25 out of 25 points. And that's just a quick demo of how you can kind of have this iterative feedback cycle. Now, this is a very complex cycle. There's a lot of things that are happening for this one little hello world example. But as you start to have more robust assignments, you're doing something like A/B testing, or you're doing multiple features simultaneously. This type of workflow makes it really easy to interact with students on teams and students that are working on simultaneous features, as well as like keeping them moving along. So this is maybe a little bit overly complex for hello world, but as the problems that your students encounter become more complex, this workflow really starts to support them more and more. So with that, I'm actually going to stop here and jump back over to my keynote and jump down to this slide and just ask if anybody has any questions and be able to handle questions as needed.